Hello guys and welcome! I hope that you're doing well. My name is UHDking, or I play 4K, AK, I play 8K, AK, I play 16K, and during this video I'm going to demonstrate Warhammer 40,000 Dawn of War 3 PC game that is a real-time strategy for Warhammer 40,000 and still a beautiful looking game in 2023. But today I'm going to demonstrate as world's first 16K video resolution gameplay, 16K video resolution benchmark at all kind of different presets, which will be 16K UHD or 16 divided by 9 aspect ratio of 16K video resolution, which is 132.7 megapixels. Let me real quick go ahead and demonstrate for you that let me bring the magnifier zoom tool. As you can see, I'm using the Windows magnifier zoom tool. Let me real quick go ahead and demonstrate for you that my desktop is set to 16K video resolution. Okay, let me bring the magnifier zoom tool all the way to 1600%. If you're gonna do it under 4K video resolution, everything will be so blurry and pixelated, and it's not going to be as sharp as this. And as you can see, 100% display scale. Okay, even if I can run 500% as recommended for this particular game, it's still going to be the same FPS. But just in case, I decided for those naysayers, for those haters, to do 100% scale. And I will try to do all type of 16K UHD or even 8K UHD at 100% scale. Keep that in mind. So 1600% scale on the Windows magnifier zoom tool, 15,360 pixels on width and 8,640 pixels on height, which is 132.7 megapixels, will be rendered per each frame in real time. Okay, let me zoom out. In the end of this video, I'm going to introduce you to my PC specification within the details, and throughout this video, we're going to talk a lot about it. Okay, let me zoom out and let me actually bring it right here, the magnifier zoom tool. As you can see, guys, at the right top corner, this is 4K video resolution. This is how 4K video resolution looks like on 16K video resolution, 16K UHD. This is how 4K UHD looks like. So you can pretty much place 16 4K UHD screens on single 16K UHD screen. Today I'm using the Nvidia driver that was modified or hacked, and today I'm using the Nvidia ShadowPlay that was also modified or hacked. So it's capable to record on Turing GPU architecture, which is RTX 2000 series video cards, in 8K video resolution through the Nvidia ShadowPlay, even if it doesn't support it natively by the Nvidia, but that capability is ready for the Turing GPU architecture if you're going to look in the manual by Nvidia ShadowPlay. So unlock that capability. I believe that Nvidia unlocked that capability and that was ready for the AV1 video codec that's going to be supporting 8K UHD video recording through the Nvidia ShadowPlay for RTX 4000 video cards. However, the RTX 2000 video cards in Turing GPU architecture such as Titan RTX video card and RTX 2080 Ti video cards was ready to record 8K UHD 16 divided by 9 aspect ratio in Nvidia ShadowPlay. Let me zoom in and show you that this 4K video resolution. Look, everything is so sharp. Yes, indeed, we're running that. So I'm going to start with the minimum possible preset, and I know for 16K video resolution you want to keep your texture detail at the maximum visuals, otherwise what's the point? But I decided to go ahead and give it to some folks that try to do all kind of different benchmarks. This is going to be an extra bonus. Don't forget to smash that like button. This is just for you guys. I'm going to do texture detail low, and then I will switch it to maximum texture detail, because what's the point is again to run 16K video resolution not at the maximum, and we're going to bench only at maximum. But low preset that. For the texture detail, we're going to be an extra bonus. Please watch this video on 4K UHD in your YouTube player as minimum. But for the best possible visuals, 8K UHD. I'm going to upload it in 8K UHD as I'm recording right now. It's going to be crystal clear and beautiful visuals. So I'm going to try image quality at minimum. So right now everything will be at minimum, but it's going to be 16K video resolution. I'm going to switch 4K UHD to 16K UHD in 1 second, and we're pretty much going to try all kind of different presets. Okay, so let's go ahead and keep going, guys. So what I'm gonna do real quick, let me change the preset to 16K video resolution. Here we go, 15,360 pixels by 8,640 pixels. And it's outputting the signal to a native 8K screen today, but it doesn't matter, guys, if what signal it's outputting through the port. It's still rendering 16K UHD, keep that in mind. Titan RTX video card doesn't support 16K UHD on a single cable anyways. Even the AMD GPU architecture doesn't support 16K UHD at 60 Hz, as I believe, if I'm not correct. If I'm correct, and I'm correct, guys, based on manual by Nvidia. So Titan RTX can only support 4 8K screens at 30 Hz to be able to create an array out of 4 8K screens as 16K video resolution native. Okay, but ADA GPU architecture will support 4 8K screens at 60 Hz, and to be able to create 16K UHD 60 Hz screen out of the 4 8K screens at 60 Hz. Hopefully, guys, this makes sense. Okay, so I'm going to go ahead and apply that, and instead of windowed mode, let me apply actually that. I'm going to switch from a windowed mode. I'm going to switch to here we go. As you can see, I apply that. Right now we're running indeed 16K video resolution, but in windowed mode, because as you can see right there at the left, the top, really top, we have that windowed mode. Let me zoom in to demonstrate it for you. And I'm going to get rid of that Dawn of War. The reason why I'm still going to run in windowed mode, but it's going to be borderless window mode, because I like to use the zoom tool, Windows magnifier zoom tool, to zoom in to show you some details. Yes, indeed, that we are running 16K UHD and everything will be so sharp and beautiful. And to be able to do that, I need to run in windowed mode or borderless windowed mode. But borderless windowed mode under DirectX 11 API under Windows 10 Professional, it's still going to show you the same performance as the full screen, plus minus 1 FPS. It doesn't matter. Okay, Titan RTX video card is overclocked. Let me bring the stats. At the left top corner, as you can see, the data updated every single second. The data is verified and self-explanatory. You're going to keep your eye and focus at the left top corner. We're going to talk a lot about it. Okay, as you can see, my Titan RTX is overclocked. Alright, so I'm going to apply that and we're going to run it. Here we go. 30 seconds. Every time I'm going to switch the preset in this particular game, which is Warhammer 40,000 Dawn of War 3 PC game, we gotta reboot completely the game because it cannot reinitialize the DirectX 11 API in real time, just to clean the garbage collector and make sure everything is reinitialized correctly and we're gonna run correctly the preset. So this is how we're gonna try it, guys. So we're gonna start with the lowest possible preset, and the game has pre-built benchmark. This is very great ability for any game to have pre-built game benchmark. Kudos to game developers. So let's go ahead and execute that, guys. And as you can see right now, I'm running in the borderless window mode. I'm gonna go ahead and start. The maximum font at the left top corner that can be used for the MS Afterburner in 2023 with the latest version. I cannot go bigger than that. It's not scaling because the resolution at mine. Alright, so because 4K video resolution is 8K megapixels, video 6 megapixels and 16K video resolution, 4 times of that, which is 132.7 megapixels. Okay, to try to test this game on a single Titan RTX video card that I'm running today in 12K resolution as well. I think the game doesn't support SLI, so if it doesn't support SLI, I'm only going to try on a single Titan RTX video card. So as you can see, guys, today I'm running single Titan RTX video card equipped with 24GB of video RAM, which will be Turing GPU architecture, which is the same GPU architecture as a flagship for the RTX 2000 series as RTX 2080 Ti video card. Only RTX 2080 Ti video card has 256 CUDA cores less than Titan RTX, which is the full TU102 GPU, just like on Quadra's RTX 6000 and Quadra RTX 8000 video cards. But Quadra RTX 6000 and RTX 8000 video cards has the registered video RAM, and on Titan RTX it's unregistered video RAM. And the difference will be that unregistered video RAM can produce some mistakes and drop frames, while registered video RAM will never drop a single frame and it will render exactly what it is. So as you can see, so it's a TU102 GPU by Nvidia or Turing GPU architecture flagship equipped with 24GB of video RAM, while Quadra RTX 8000 video card based on Turing GPU architecture TU102, the same GPU, is equipped with 48GB of video RAM. And unfortunately that video card is very rare and very expensive, but it's nice to see how Quadra RTX 8000 video card can perform this test with 48GB of video RAM, because as you can see at the left top corner, with the minimum possible preset, I'm already running 24,000 megabytes of our video RAM. That means that I'm overloading my VRAM based on system RAM, because the system RAM is 32,000 megabytes and total system RAM that I can use today is 32,000 megabytes actually of my system RAM. So I'm overloading my video RAM and I'm overloading my system RAM. I'm using a little bit of the storage device. After it's overloading the video RAM, it's using the system RAM, and then it's using the storage, which will be the SSD drive on my Windows installation, which is C Crucial MX500. It's going to be SATA 3. Not fast enough, so the FPS will be dropped by a couple FPS for sure if we're going to compare the same Turing GPU architecture but with 48GB of video RAM. So I'm going to compensate that overload. So we are overloading, I would say, probably around 16, maybe even more, 18 or even 20,000 megabytes from a video RAM into the system RAM. Okay, maybe even more than 20,000 megabytes or 20 gigabytes, maybe like 22,000 megabytes or 22 gigabytes, and offloading about 2 gigabytes into the system RAM. I mean, from the system RAM into the storage, which is the slowest possible offload based on NVIDIA driver. Okay, so minimum FPS 13.26 FPS, maximum FPS 20.06 FPS, average FPS is 15.80 FPS, so 15 FPS average, and this is within the Nvidia ShadowPlay recording. So go ahead and please add 10%. I would say less than 10%. It was exactly 6%. So go ahead and add, I would say, about 0.60. Okay, not even 1 FPS to the FPS counter. So without NVIDIA ShadowPlay recording, it should be 16 FPS average at this preset. Okay, keep your eye at the left top corner. We have the GPU utilization right now is not fully utilized. As you can see, the CPU utilization is still below 70%, but this game is heavily using the CPU. But however, I'm using the minimum possible visual presets. When I'm going to increase the visual presets, we're going to decrease the CPU load and we're going to increase the GPU load. We want to have the GPU load at 100% as our overall GPU utilization completely. That means that I'm going to utilize all the Turing GPU architecture CUDA cores, which is 4,608 CUDA cores at 100% will be all utilized without any idling or any waste. And CPU utilization, overall CPU utilization, the time, because utilization will reach 90% sometimes, sign that we gotta add additional 2 threads, and it's better be a physical threads for the best possible performance. Keep that in mind. So otherwise I'm going to probably be limited a little bit by the FPS as well, and it's going to be decided by the NVIDIA driver and Intel driver. Keep that in mind when you're going to see that 90% of the overall CPU utilization. You want to keep way below that, and I would say even try to keep below 70% for the healthy FPS, so you're not going to be bottlenecked by the CPU threads that's going to require to have more CPU threads to process that load out of the GPU. Keep that in mind on the video card. Alright, so we got it. Okay, so let me real quick, guys, as you can see, I'm explaining for the beginners, so a lot of beginners watching us. So right now we're going to do the same task, but this time I'm going to go ahead and do the texture details at maximum. So just because 16K video resolution makes sense, we want to run the maximum texture details, so I'm going to render every single pixel, because this is the reason why I'm running 16K video resolution. I'm going to accept that. Keep in mind that gameplay resolution is all the time at 100%. This is very crucial. So it's not 150%, not 50%, but 100%, exactly 1-to-1 scale as native resolution right now, which is 15,260 pixels by 8,640 pixels. I'm going to apply that. It told us that I need to reboot the game. This is exactly what I'm going to do. I'm going to return, and I'm going to go ahead and reboot the game. Here we go. It's going to take just a little bit of time. Here we go. We got it. Let me close that desktop resolution, and I'm going to start the game back again. As you can see, I'm running the Steam version. Right now it's going to load the game. Keep your Steam icon, keep your eye at the Steam icon at the left top corner by the date of 2022. But today actually is 2023. I gotta change that instead of 2022. But it's I did Warhammer 40,000. See that little icon of the Steam, how small it is? I did Warhammer 40,000 Dawn of War in 2022 in 8K video resolution, but 16K video resolution and 4K video resolution I did it in January 2023. Today is January 2023, but this type of technology was available to us all the way back and Titan RTX video card featuring GPU or RTX 2080 Ti video card, and RTX 2080 Ti video card could not handle this load because it featured only 11 GB of video RAM, while Titan RTX was featured 24 GB of video RAM. Same video RAM though, GDR6 on RTX 2080 Ti as on Titan RTX video card. Alright, so we just rebooted. Let's go ahead and check it out. And as you can see, maximum texture detail, everything else at the lowest possible preset. So let's go ahead and bench it. So we saw 13 FPS before. Let's go ahead and bench it. Let me apply just in case one more time. And I'm going to run the benchmark. You want to keep your eye at the left top corner. So we're going to decrease the CPU utilization by a little bit, and we're going to increase the GPU utilization because we're running as possible. And those little units, they textured like 2K video resolution each, and when you're running 4K video resolution, you're not even rendering at 50% details of the texture on those units. Please keep that in mind. But right, those little units, at best it could, because 16K video resolution, just 6 by 3 aspect ratio, a little bit larger than I'm running right now, which is above 132.7 megapixels, will be the maximum renderable resolution in 3D rendering real-time APIs in 2023, such as DirectX API, Vulkan API, OpenGL API, OpenCL API, CUDA API, Mantle API, and in the end of this video I'm going to demonstrate it to you as a fact, so stick around. As you can see, our video RAM utilization right now is less, and I believe the video RAM utilization was higher because I was pretty much guessing of the pixels to fulfill the 16K video resolution, but right now I'm actually running the actual pixels without guessing, and system RAM utilization is lowered as well. The CPU utilization is lowered as well, which is maximum stress received on the GPU, and GPU was excellent as you saw. So okay, alright, so minimum FPS 13.23, maximum FPS 20.63, average FPS 15.90. So without Nvidia ShadowPlay recording, we're delivered 16 FPS average. So pretty much the same deal with the texture at lowest possible preset quality and everything else at lowest possible preset, and plus the texture at the maximum quality preset. It doesn't matter, guys, as you can see. But somehow at the lowest texture detail, the video RAM was higher and system RAM was higher, but as again, it's under the menu, but not throughout the gameplay. So under the menu, it's using additional data and it's using the in-game menu, and I believe the video RAM and system RAM is so high because the garbage collector in the game didn't clean itself. There is a possibility, okay? So great results. Let me real quick close it before we're gonna jump in. I want to zoom in into this robot and I want to show you the details. Actually, I'm gonna zoom in first into that dude right there. Look how small my mouse cursor right there. Into that dude right there. Let me zoom in. Let me bring the magnifier zoom tool. This 900%, this is crazy, guys. This is like 64K video resolution and even above than that, probably like 96K, which is going to be like per each frame like about 3 gigapixels per second per each frame. This is just unbelievable. Right now I showed 16 FPS. That means that per each frame I'm delivering 132.7 megapixels times 16, so I was running around 18 gigapixels overall pixels on the screen per second, and this is unbelievable performance for the Turing GPU architecture for the single Titan RTX video card performance out of the GPU by Nvidia, which is TU102. Uh-oh. Frozen? Hopefully it's not frozen. Something is going on here. I think just because it's a little bit overloaded the video RAM. But look at those details. So 200% will be, let me bring to 200%. This will be how 32K video resolution. Look at this without any anti-aliasing. It looks so great. Every single detail, it's just unbelievable. And this is at the lowest possible preset when metal is not metal yet. The texture is not the real metal texture yet. When I'm going to increase the shader quality, which is the maximum quality in shaders, the way it's going to render those textures and apply some rendering effects is going to be on another level. But 200%, this is 32K video resolution. 400%, this is going to be 64K video resolution. Still looking great without the anti-aliasing. Check it out. But impossible to render under any 3D rendering commercial or open source APIs. 600%, which will be 96K resolution. 800%, 128K video resolution. Look, everything is so beautiful yet, and this is the lowest possible visual preset, but texture at maximum. But as again, shaders at lowest possible preset, the metal will look on another level without any anti-aliasing methods yet. This is unbelievable visuals, guys. As you can see right now, the texture getting blurry. But as again, this is without any modes, the original game. All right. I'm gonna bring to 1600%, the maximum zoom that we can use, 1600%, and right now I can see the edges right here on 3D model needs to have some anti-aliasing. I'm not sure if you're gonna see it under YouTube because while I'm recording, it's going to do the re-encode. It's going to encode the video and it's gonna blur it out. When it's encoding the video, it's going to a little bit blurred out because it's going to compress this video. Right now, I'm recording this video in 8K video resolution, but at 100 megabits per second. And if it's going to be 1 hour video, hopefully not, it's going to be like 45 minutes video. It's going to be almost 100 gigabytes file size of that video file size because it's recording 100 megabit per second, and 1 hour 100 megabit per second bitrate is 100 gigabytes of video file size. Keep that in mind. But as you can see, guys, needs to have some anti-aliasing and special right here, but this is without any anti-aliasing, but looking great, and shadows as low as possible preset 1600%. Let me go ahead and bring to a bigger model that's going to be closer, and you can see the anti-aliasing is indeed needed, especially right here. But as again, without the anti-aliasing and lowest possible visuals, but the texture at maximum. But texture at maximum has nothing to do with anti-aliasing. Still looking great. Check it out on those details, guys. As you can see, the gun needs to have some anti-aliasing. You can see the edges. See those kind of lines, breaking lines? That means that with anti-aliasing methods, we're gonna smooth it out, and it's going to be looking beautiful. We're gonna apply some method, and this is without it yet. Looking great, guys, with the lowest possible shader quality. Unbelievable. Let me zoom out. But look at this at 200%, even the largest model. As you can see, it's rendered in real time within the game engine. This is not the video, this is not preloaded video, this is rendered within the game engine. This is 32K video resolution. Still doesn't need to have no anti-aliasing, and even if you're going to have real estate of the screen 200 inches, let's say you're gonna build up out of the 485 inches screens 8K from 2021 LG or Samsung in 8K video resolution native, each of them will cost you below $2,000. So with the taxes, $8,000 will be 4 8K screens from 2021. Beautiful array of the 85-inch each screen, which will be 4 times, which will be 320 inches of the array in 16K UHD, and you can use it. Depends what kind of video card. Titan RTX can only support 30 Hz, but as again, it's going to be benchable status, but not very comfortable gameplay status. But either GPU architecture or the Ampere GPU architecture, which is GA102 or AD102 GPUs by Nvidia, supporting 8K at 60 Hz per each port, per each output port on a video card, and it's going to be amazing, guys. It's going to be 320 inches array of the 16K screen real estate, and it's going to be beautiful, guys. All right, so let me go ahead and jump in. So I demonstrated lowest possible preset, and then demonstrated for the haters and naysayers the benefits of the 16K UHD and 16K 4 divided by 3 aspect ratio, which is old school aspect ratio, is going to be on another level. But anyways, so let's go ahead and switch it now. So what I'm gonna do, graphics, I'm going to switch it to medium now. So image quality, I'm just going to increase the image quality. So for medium, I'm not gonna test the low, I'm gonna go and jump into medium, and then I'm going to show you high and maximum preset, which will be actually medium. Then I'm going to show you high and maximum, yes, because there is going to be difference in terms of the FPS and visual qualities. Still, guys, with no physics, without the anti-aliasing, without unit occlusion, kinda medium preset indeed. VSync is off to demonstrate the maximum possible FPS. Make sure your VSync is off. I'm going to apply that, and it's gonna tell me I don't need to have any reboot, but I'm going to reboot it just in case, because this game engine struggling to with all kind of different presets, just in case. So let's go ahead and do that. Return. It's already lagging pretty badly, guys, in the game. Keep that in mind. Hopefully it's still recording with Nvidia ShadowPlay. When I'm overloading a lot of my video RAM and system RAM, sometimes it's stop recording and such automatically. And as you can see, I'm using right now last video RAM in the menu, but the reason why we didn't run the benchmark yet, and I believe the video RAM and system RAM utilization is so high after the benchmark, as again, because the garbage collector for the video RAM and system RAM is not cleared correctly within the game engine. This is what I'm assuming, because under DirectX 11 API it should be cleared correctly, but look like they're artificially utilizing that garbage collector. They're creating the garbage collector, and they're not refreshing the garbage collector and still holding that video RAM and system RAM even if it's not used. Keep that in mind. Let me go ahead and run it again. So medium preset, Let's go ahead and have a look. As you can see, 6 cores, 6 threads more than enough. And the higher resolution, the better GPU utilization will be, and the lower CPU utilization will be. Exactly what we want to see. We want to have the CPU utilization as low as possible, especially below 50%. That means we're guaranteed below 50%. Do not need to have any additional threads or any additional cores because we're not going to benefit if you're going to add them. But GPU utilization is, again, we keep at least 10. Means that 0 CUDA cores are wasted. Nothing is idling on the CUDA cores, and everything is performing computing in real time in this Warhammer 40,000 Dawn of War or Warhammer 40K Dawn of War 3 PC game. Warhammer 40,000 Dawn of War 3 PC game, which is the latest series for the strategies, for the real-time strategies, and absolutely amazing. Guys, it's lagging, but the visuals are unbelievable. Let me zoom in a little bit. As again, I'm not trying to do as fast as possible this benchmark. I'm trying to cover every single detail because this video will be as informative as possible while covering all kind of different details from any kind of point of views and any kind of angle, no matter what kind of industry you're in. But because this is the world's first 16K video resolution in Warhammer 40,000 Dawn of War 3 PC game, look at this. Everything is almost anti-alias. This is 400%. This is 64K video resolution. Everything looking beautiful. The game is kind of lagging badly, even at medium preset. But right now, I don't see those hard edges. A little bit seeing that at 700, at 800%, but not that much. And this is at the closest possible model, as you can see, 1000%. Check it out, guys. The level of details of the share is not that beautiful, as you can see, in terms of the bump mapping and parallax mapping. It can be increased and can be better. As you can see on his eye, the share is right here, the edges needs to have some anti-aliasing. Let me use the 1600% all the way on zoom, under Windows magnifier zoom tool, and you're gonna see it. Alright, so this is without the anti-aliasing. Hopefully you can see it. Hopefully it's not gonna blur out through the two type of encoding with Nvidia ShadowPlay and encoding through the YouTube. I'm not gonna recompress this video, keep that in mind. Alright, so this is 1600%. Let me go to as small as possible. Look at this, we almost can read the details of that texture right here. What does it say? It's probably in their language and kind of hard to see, but let's go ahead and compare the maximum visuals under the maximum visuals. Alright, this is still medium visuals, and I can see his hat needs to have some anti-aliasing the edges. The textures are much better now. The metal is looking almost like a metal. I really like that specular maps and the normal maps. On the diffuse map, which is diffuse map, a regular texture, especially that metal right there, it's almost reflecting. I can see the shadows. It's kind of noisy, but when we're going to improve the visual quality, I'm pretty sure it's going to disappear. Alright, so this is 1600%. It's looking beautiful, but not at the level yet. Let me zoom out a little bit. So I'm just going to zoom out some percentage. But if I'm going to use 200%, it's going to look beautiful, guys. You're not going to see any hard edges at all. It's going to be just like 16x anti-alias. It's going to be looking beautiful. So this is 200%, right? This is, no, this is actually 200%. This is 100%. This is 200% right here. Look how beautiful. Everything is just beautiful, guys. This is just unbelievable. I mean, can you do better than that? I'm going to take a screenshot. Let me for this video, let me move the magnifier zoom tool. It's going to be, I'm probably gonna do at maximum visuals. Yeah, let me do at maximum visuals. But anyways, this is just unbelievable. Let's go ahead and start the benchmark now. So I demonstrated to you the game engine. As again, this is rendered, the menu is rendered with the game engine. Proper approach, but when you're using the menu rendered with the game engine, you do not allow the video card to cool. So always think outside of the box. Maybe when user is putting into the game menu, taking a pause somewhere, drinking tea, or calling his body, or doing something else, maybe he wants to cool his video card, and it's not a super great idea to use the game engine throughout the game menu. As again, this is my advice to you as a software developer, game developer. over the UHDking.com YouTube channel, guys, we're gonna talk a lot about software development as well, game development, graphics design, 3D animation, besides the gaming and gameplays and ultra extreme maximum visuals as maximum video resolution. It's going to be all kind of different and great videos regarding the computer science. So go ahead and smash that like button, support me, guys. A lot of time, money, energy is invested, and subscribe. Share it with your friends. This is unique channel. You definitely don't want to miss out. This is where you're going to gain some skills, some information, some details, and learn a lot from me, from UHDking, because I have over 10 years experience in as 3D animator, graphics designer, software developer, so a lot of and gamer, almost 30 years. A lot of information will be shared with you. So medium preset. Okay, let's go ahead and start the benchmark. It's time to do that. It's lagging badly, guys. It's unbelievable, and you can see by that MS at the left top corner. MS stands for the latency delay in terms of the milliseconds. At the left top corner by the FPS, 500 milliseconds latency delay. The latency delay, the lower value is better. The FPS, the higher value is better. That means that latency delay is the delay between the hardware and software, and hardware will be GPU, video RAM, CPU, system RAM, and software will be Windows 10 professional operating system in our case, Nvidia driver, DirectX 11 API, game engine, and it's all it's all creating that latency delay before each frame is rendered. 500 milliseconds takes to render every single frame. Keep that in mind. So 1 FPS per second. This is just unbelievable. Alright, I smashed that apply button. Let's go ahead and run the performance test. Hopefully it's not going to crash on us. But it's badly overloading. But it's under the menu. It's badly overloading our video RAM and system RAM. But as you saw throughout the gameplay, it's going to get much better, because I think it's using like 2 different layers while it's rendering in real time, and the garbage collector is not cleared, so it should not render the secondary and background layer, but it does, being that into the video RAM and system RAM in the game engine garbage collector, and it should be cleared. But as again, the game developers didn't pay too much attention, so you want to pay the attention, guys. As you can see, a menu like this with a static image will be much better, because it's cooled down the GPU and lowering the system RAM. It's pretty much let's say you pause the game, you want to cool down your video card, you want to consume less energy while you're doing the game. If I'm going to develop a game, so I'm not going to utilize game engine for my menu, that's for sure. But it's great looking approach. Look, everything is just unbelievable, and this is medium preset. Look how beautiful it is. That little unit right there has the texture 2K video resolution, which is 2048 by 2048. So when you're running 4K video resolution, that unit right there is not even utilizing 50% of the texture details in terms of the pixels. But right now, I believe that unit is around, I would say, maybe 1024 pixels by 768 pixels, so almost utilizing 50% of the texture in that unit, if it is 2K video resolution per texture, which is 2048 pixels by 2048 pixels. This is for those naysayers that telling me that I'm upscaling the textures and blurring them out, the pixels details. I'm not. You do not understand. I'm not blowing the texture in the full screen, every single texture. Those texture at some distance, because this is how 3D animation and 3D graphics is. At some distance by XYZ. Hopefully, guys, this makes sense. Guys, it's looking absolutely amazing, the level of details, and this is medium preset without any anti-aliasing. Video RAM utilization is 20,000, almost 21,000 megabytes, which is 21 gigabytes of our video RAM utilization, and system RAM utilization below 13,000 megabytes, which is below 13 gigabytes. And in the menu, it's going to increase again to the maximum, because it's not going to offload through the garbage collector the background video RAM and system RAM utilization, so it's going to be kind of double video RAM and system RAM utilization. But as again, hopefully it's not going to crash the video recording. But if it's going to crash the video recording, this is how I'm going to upload it, guys. I'm not going to, this is a single take, I'm not going to retake it. And I will try on the two Titan RTXs and SLI. Some people are saying the SLI is supported. I'm going to go ahead and try it. If not, then we're going to try it on Nvidia RTX 3090 video card, Nvidia RTX 3090 Ti video card, which is the Ampere GPU architecture flagship, equipped with 24GB of video RAM, and then we will try to render it on the RTX 4090 video card, but it's not the full 80 GPU architecture, it's not the full 8102 GPU by Nvidia. It's still featuring 24GB of video RAM, and as you can see, 24GB of video RAM, when I'm going to switch to maximum visuals presets, it's not going to be enough under the maximum graphics preset. So I would say 48GB of video RAM for the Warhammer 40,000 Dawn of War 3 PC game is required to run this game benchmark or the gameplay in 16K video resolution without a single video RAM offload from a system RAM into the video RAM. I mean, from a video RAM into the system RAM. Hopefully, guys, this makes sense. As again, I'm coming in real time. I'm not reading this information. So we're paying our attention at the left up corner. As you can see, GPU utilization 100% exactly. Every single CUDA core is utilized exactly the scenario that we want to see. The CPU utilization was not even at 50%, which is excellent CPU utilization. A zero bottleneck through the CPU threads or CPU cores. We're only bottleneck through the CPU instruction per clock. Keep that in mind. The newer CPU generation will show higher instruction per same clock. Keep that in mind. And it's going to be clocked at the higher frequency as well, all the way to 6000 gigahertz or 6000 megahertz per each core on the Intel Core 13900K or any 13000 series. You can overclock your CPU almost on any CPU, including 13700K, and you can also try 13600K overclock to 6 gigahertz if you are smart enough. I'm going to create a video tutorial how to overclock the Intel Core i9-9900K at 5.3 gigahertz, how to overclock the Titan RTX video card, how to overclock RTX 2080 Ti video card, and future CPU and GPU will be available with step-by-step instruction, guys, when everything will be explained over the UHDking.com. Go ahead and check it out. Anyways, minimum FPS, almost 1 FPS without Nvidia ShadowPlay recording is going to be 1 FPS, but otherwise it's 0.93 FPS. Maximum FPS 4.46 FPS without Nvidia ShadowPlay recording is going to be 5 FPS, I'm pretty sure. Average FPS 1.70 FPS, which without the Nvidia ShadowPlay recording is going to be 2 FPS average. Okay, we got it, Houston, we got it. Let me close that. It's lagging pretty badly, guys, because as you can see, video RAM is not enough, system RAM is not enough, and it's offloading a lot of data into the storage device, which is the slowest possible pre-caching for the GPU, pre-caching the data. After the level first cache, then level second cache, Nvidia video cards using 2 ways of the pre-caching on the memory that built into the video card, and then it's using closest to the GPU, and then it's using video RAM as a torrent resource, which is the slowest possible on the video card, and then it's using the system RAM, which is the slowest possible after the video RAM, and then it's using the storage. Hopefully, guys, this makes sense. So what I'm gonna do, I'm going to go ahead and increase now to high preset, not the maximum but the high preset, and then maximum. It's going to look, guys, absolutely fantastic. I already can tell, but as again, I didn't try it yet, so hopefully it's not going to crash on us. As you can see, anti-aliasing will be off, physics will be off, but maximum texture details, image quality high, unit occlusion is off. At maximum visuals, I'm going to also try to include the unit occlusion as well. Okay, so we're gonna apply that. I'm gonna reboot the system. It's lagging so badly, like unbelievable, guys. Just in case, I'm gonna reboot the system, so it's going to initialize the resolution and presets correctly throughout the DirectX 11 API. Okay, Let's go ahead and do that. Look how small my mouse cursor is. Just unbelievable, guys. You gotta get used to it. But then you're gonna get used to it and it's no problem. Okay, we quit that. So now it's going to be high preset without the anti-aliasing, without ambient occlusion. So not the maximum visuals yet, without any physics. Yeah, take you even to close the game, because I believe the game engine is uploading some data from a garbage collector and it's taking some time, and it was so much data into video RAM and system RAM. Alright, so let's go ahead and boost it up. As you can see, Titan RTX is overclock, of course, plus 100 MHz on the GPU and plus 1300 MHz on the video RAM, which is outputting as external frequency throughout overclock 2600 MHz additional through the free. Okay, it's beautiful looking game, still a great strategy in 2023. If you into the RTS games, which is real-time strategies, this is going to be the game for you guys. You're gonna enjoy. So I'm gonna skip that pre-rendered video. I want to see the rendered video because that while the menu and everything is rendered in real in that resolution, there's a big difference. Okay, it's taking longer than usual. Here we go. Okay, let's go ahead and verify the resolution and everything. So high image quality, texture quality maximum, anti-aliasing off, physics off, unit occlusion off. Unit occlusion actually is taxing some GPU performance capabilities as well as video RAM utilization. So I'm going to go ahead and start run performance test. As again, kudos to developers that integrating the benchmark into their PC games or into their software. It's very handy and neat. So we can benchmark our computers and compare and build much better computers, much better systems while running the benchmarks and understand the difference in terms of the performance. Okay guys, high preset, and next one will be the maximum visuals. So if it's going to quit the Nvidia video recording, I'm not going to re-record this video. Please keep that in mind. Going to quit the Nvidia ShadowPlay and it cannot proceed. That's why it's going to tell error. So it's going to catch that error. Alright, let's go ahead and have a look. Of course, the GPU at 100%, not a question. The CPU utilization is 14%, not a problem, not a biggie. Guys, the visuals are beautiful. Every single detail right now over here, every single pixel. And this is yet not the maximum visuals. Okay. As you can see, it reminds me a little bit of StarCraft. Guys, also check out the 8K video resolution in Warhammer 40K down on 4.3 PC game. I did it. I will try to do 4K video resolution on single Titan RTX video card. Hopefully we are not going to reach the maximum FPS cap, so we can benchmark it with the future GPU architecture and future video cards and future PC systems. And I'm going to try to do 12K video resolution. It's nice to see 12K video resolution. That will be 3 8K video screens in vertical mode. So minimum FPS, almost 1 FPS. So it's going to be 0.99 without the recording. For sure it's 1 FPS without the recording in real time, because right now I'm recording in real time. Please keep that in mind. Maximum FPS 10.75 FPS, so for sure 11 FPS. And average FPS is 7.43 FPS. But as again, without Nvidia ShadowPlay recording, most likely almost 8 FPS average. Alright, we got it. Houston, we got it. It's lagging pretty badly, guys. As again, just because the video RAM is not enough and system RAM is not enough, because it's 32,000 megabytes is our system RAM, so it's offloading the data into that storage, and that storage is such a slow for any type of operation at this type of bandwidth that the GPU is capable to push and CPU is capable to push in real time. So maximum possible visuals without a unit occlusion yet, without any anti-aliasing, without any physics. I'm just gonna set the maximum visuals and we're gonna see how it's going to look like. I'm going to apply and reboot the game. Here we go. Okay, data, data, data. Okay. And I'm going to reboot the game, of course. Come on, come on. Here we go. Return to menu, and now, guys, I'm going to zoom into that model at the maximum visuals just to demonstrate capability. You can see that without the anti-aliasing, it's going to look just stunning. Okay. Guys, I'm going to go ahead and pour some more coffee when it's going to start benching, but you want to keep your eye at the left top corner. So I'm gonna start it over. As you can see, the CPU utilization was evenly, great multi-threading performance, and not even half per each core. And they synchronized in terms of the utilization, which is excellent multi-threading ability throughout the game engine. Okay. Alright. Hopefully it's not going to overload your RAM. Okay. Taking longer time than usual. And this is not yet the maximum visuals. Let me see. Not exit the window. I wanted the menu. So hard. The mouse cursor is just a small. I just was playing a lot of in 8K video resolution. I was designing the cinematic mode while I'm going to utilize the artificial intelligence for Quake 1, Quake 2, and Quake 3 and Stalker game series, and it's going to bring those games to another level, guys. But that mouse cursor is just killing me. Anyways, I didn't get used to it, but you're gonna get used to it after a couple days. So maximum visuals, image quality, texture details, maximum visuals. This is without the anti-aliasing at all. We go ahead and demonstrate it for you guys, and I'm gonna go ahead and grab some coffee real quick. You wanna keep your eye at the left top corner, and I'll be right back. Okay. I'm using the artificial intelligence. It's diffusing my voice. It's going to disturb my voice a little bit, but I don't think that you're gonna hear in the kitchen how it's brewing the water. Guys, it's just such a clear, beautiful visuals. This is just unbelievable. So video RAM utilization is almost 21,000 megabytes, which is 21 gigabytes. Still 3 gigabytes to go. So probably still healthy video RAM utilization. System RAM utilization below 14,000 megabytes. You can see the system RAM utilization compared from the lowest preset under the benchmark versus the maximum preset. So the difference after we're going to overload our video RAM will be exactly what we're passing from the video RAM into the system RAM because the video RAM is overloaded. So below 13,000 megabytes is our system RAM utilization on average, as you can see, within the healthy video RAM utilization. But what I find out, guys, Titan RTX video card is offloading the video RAM into the system RAM after 20,000 megabytes for this particular video card. And I believe it decided by the Nvidia driver, not by how much it's left, but by the percentage, how much it's left as a percentage to go as free that can be loaded. And I believe when it's like 10% left, for sure it start offloading the data from the video RAM into the system RAM just to compensate, just to be on the safe side before it's going to overload the video RAM and crash the game engine and crash even the Windows or the Nvidia driver or lose the 3D surface, which is happening under the DirectX API because it's called the 3D surface. Some are calling 3D canvas, some rendering API, some calling 3D world. So 2 FPS average, the latency delay above 600 milliseconds. So as again, latency delay in terms of the MS, the lower value is better. FPS in terms of the frames per second, the higher value is better. The latency delay, comfortable gameplay will be below 20 milliseconds. The absolutely great gameplay will be below 10 milliseconds, and absolutely amazing gameplay will be below 5 milliseconds in terms of the latency delay. As you can see, we're 100 times above of that. And 2 FPS average, so the comfortable gameplay will be above 120 FPS. I mean above 60 FPS, the comfortable gameplay, but amazing gameplay will be above 120 FPS, guys. One second, I'll be right back. Alright guys, I got myself some coffee because this is going to be the fourth video today that I'm recording. Today I also recorded how I'm developing using the AI UHDking's ray tracing CPU benchmark, and I'm gonna show you guys how I'm utilizing the AI and how I'm developing. I will try to do as transparent as possible. So decided to get myself some coffee, so I'm gonna get some energy because I'm recording already for almost 8 hours and I'm losing some energy. And my voice can be a little bit squeaky because I'm talking and talking and talking throughout multiple videos that I'm going to upload over the UHDking.com that you don't want to miss, especially that AI software development when I'm going to go key by key while I'm going to utilize the Chat GPT, which is the artificial intelligence by the OpenAI company, which is amazing. Anyways, minimum FPS 0.88 FPS. This is within the Nvidia ShadowPlay recording, so without it, it's going to be 1 FPS average. This is what I'm assuming, which will be 6%. Maximum FPS will be right now is 4.42 FPS, which will be almost 5 FPS, a little bit below 5 FPS without Nvidia ShadowPlay recording. Average FPS is 1.68, and without Nvidia ShadowPlay recording, I would say it's going to be 1.9, almost 2 FPS average. And this is not, let me close that. It's lagging pretty badly, guys. It's just unbelievable. This is maximum visuals, but without any anti-aliasing, without any ambient occlusion yet. I decided to test it like this for extra bonuses, for extra details, as again the world's first 16K video resolution benchmark in Warhammer 40,000 Dawn of War 3 PC game. Why not, right? As the first point of data towards the 16K video resolution vector direction. And we're gonna test this game a lot, guys, in the future with the future video cards, future PC systems. So let's go ahead and enable the ambient occlusion now. So as you can see, the frames per second with current settings predicted by the game engine is correct. They did a good job. So I'm going to go ahead and unit occlusion. This is going to be taxing a little bit higher video RAM and a lot of GPU. So I think it's going to be 1 FPS. So unit occlusion is enabled. So unit occlusion, what it is pretty much it's going to create an extra layer like inner shadows, that ambient occlusion map as a texture, and it's going to blend in with the shadows. Compilation those two textures together, and is going to kind of reflect the light and create an additional kind of shadows artificially through the methods of the blending some textures together, like a diffuse map and ambient occlusion map together, and it's going to generate around the edges of the model additional shadows or whatever the designer will decide, and usually it goes around the edges of the 3D model. Alright, where the polygons are connected together, those hard edges. Enabled. Let's go ahead and apply, and I'm gonna reboot it. As you can see, automatically the game engine saying 1 FPS will be average, but let's apply, and I'm gonna reboot it. Apply. It's lagging pretty badly, guys. I don't think I even need to reboot. As you can see, I smashed that apply button. It didn't broke the window for us, so I don't think we need to reboot the game at all. Didn't even tell us that it changed that. Let me try to do it one more time just in case. If it doesn't broke the window, that means that we're Gucci. We don't need to reboot the game engine. It's already going to take it and apply it automatically. It's not a big deal, look like, through its game engine. Are you sure to want to run the benchmark test? Yes, and it's going to be like unbelievable slow, guys. It's painful, I know. It's pretty much like an animation, like a oops. Oh, look, it's such a slow. You can see every single frame when it's updated. I will try to use the zoom tool because the FPS is 1 FPS anyways. I will try to use the zoom tool to demonstrate the visuals, how beautiful the game looks like under the 16K video resolution maximum visuals that we are running right now without the physics. Physics will be additional kind of animation with the ragdoll bodies, but and how it's reflecting towards the physics in the game. But just to show you how the visual looks like, and it's going to be, look at this, it's 10 FPS, something happens. Wait a second, what happened here? We'll lower it in terms of the latency delay below 200 milliseconds and increase in terms of the FPS. Something happened here. And guys, I saw something like this a lot when I was overloading a lot of VRAM, especially in Cyberpunk 2077 as well. Something happens with NVIDIA driver, and then it's compensating and boosting up the FPS. I'm not sure why it is, but maybe NVIDIA driver is using the DLSS automatically, even if the game doesn't support, but maybe it's studied the preset by the tensor cores by the NVIDIA. I'm not sure, I'm assuming as the game developer. But look, it just completed so fast, and it's completed so fast. Something is going on here, and I'm not sure what happened. As again, this is in real time. I didn't boost it up. This is how it was, and I saw something like this in Cyberpunk 2077 and all kind of different games as well. When it's heavy video RAM overload, including the system RAM overload, something is going on. Something happens when these presets are very heavy on the GPU as well. Maybe it was using artificial DLSS applied while NVIDIA driver decided so, even if the game doesn't support. There is a possibility. As again, I'm using the driver from the late December 2022, which is the latest possible capabilities for the RTX 2000 series, which is the first generation of the RTX ray tracing gamers video cards and all kind of newer video cards that supporting ray tracing, such as RTX 3000, RTX 4000 series. The driver from late November, beginning of December 2022 will boost up a little bit of the performance, and maybe it does so while Nvidia brings some on board some DLSS through the artificial, through this tensor cores, even when the game is not supported. I'm not sure what it is, but it is what it is. You saw it. Minimum FPS 1.37. By the way, it was a surprise for me as well. Maximum FPS 10.70, which is great. Average FPS 7.6, which will be 8 FPS without Nvidia ShadowPlay recording. I'm not sure what happened there. Something happened there. Maybe it's uploaded a lot of data into the storage instead of system RAM. I'm not sure what happened. Decided by the driver after analyzation that it's going to be Gucci and game is still going to run great. But as you can see, frames per second, the game engine predict correctly. But then something happened, and the game engine doesn't understand what happened because it doesn't support that technology. As again, there is a possibility artificially forced DLSS by Nvidia. And it still was great visuals, by the way. I'm not sure what happened there. Let's go ahead and enable the physics, and we're gonna go ahead and put our eye at it again. And then if FPS will be 1 FPS, I will try to zoom in to show you how beautiful the game looks like. If you're gonna build in from 4 8K screens the 320-inch array out of the 485-inch per screen 8K video resolution, it's going to be, guys, just beautiful. It's going to be on the whole wall, and it's going to be beautiful. Make sure the frames of your 8K screens are a little tight and almost invisible, so you can stitch those screens in one 16K video resolution screen seamlessly. When I apply that, probably also needs to reboot. I will reboot if it's going to do it again and to test that it will happen. But as again, I saw something like that was happening with the Cyberpunk 2077 and some other games. At the scenarios when it's heavily overloaded. Just go ahead and check out 15,360 pixels by 8,640 over the domain name that is going to be dedicated to 16K UHD videos, which will be 15,360 times 8,640.com website. Go ahead and check it out. Or iplay16k.com, another website dedicated to 16K gameplays. Will be dedicated to all kind of 16K video resolution, UHD, no matter gameplays or rendering or graphic design or vision. It's all the information where I'm going to share with you valuable information if you into 16K UHD besides the gameplays. But if you into just gaming in 16K video resolution, like 16K gaming, 16K gameplays, you want to check out 15,360 times 8,640.com. Alright, let's go ahead and have a look if it's going to do it again. This is something new, by the way. I already saw it a couple times, but it wasn't that dramatic boost. I saw it was like 4 FPS versus 1 FPS, but it just boosted up immediately by a lot. And in terms of the pixels, I didn't see any difference. It was just the same pixel details, guys. But as again, go ahead and watch it on the video. Maybe it just happened too fast and I didn't pay attention. But right now I'm very close to the screen, like 15 centimeters away, not even 1 meter, and I'm watching pretty closely if it's going to do any pixels details. Look at those. Every single that unit is using 2048 pixels, and right now under 16K video resolution it's about 1024 pixels per every single that unit in terms of the textures. So if you're not under 16K video resolution in this particular game, Warhammer 40,000 Dawn of War 3 PC game, we're not loading 100% texture details on every single of that unit. But I'm just curious to zoom in and check it out. I'm going to zoom in, guys, in a second. I'm going to try to run this test again just to zoom in and just to see what's going on. Video RAM utilization still below 24,000 megabytes. So throughout the gameplay, video RAM utilization still will be below 24,000 megabytes. So actually 24 gigabyte of video RAM on the Nvidia video card will be Gucci. But on the AMD Radeon video cards, you need to have 30% less of the video RAM because AMD Radeon video cards are using better texture compression methods, texture compression algorithms. Developed by the AMD. It's a little bit better than by the Nvidia. Nvidia using 30% higher video RAM utilization. This is what I learned, guys, while I was testing 4 Radeon R9 290s in Crossfire back in 2014. And as again, I was the first YouTuber that demonstrated for you world's first 16K video resolution gameplay all the way back in 2015. It was on 4 Radeon R9 290 in Crossfire, and it was Counter-Strike Source PC game. No, it wasn't Counter-Strike Source. It was Counter-Strike 1.6 PC game before the Counter-Strike Source. But it was over different YouTube channel, and over the UHDking .com YouTube channel I demonstrated 16K video resolution gameplay all the way back in 2016. In the early 2016, about 6 months before the Linus did. The Linus Media Group did. I did 6 months before them. But I did 1 year at least before them, but it was over different YouTube channel. I closed that YouTube channel, so it's not available. But as a fact, over this YouTube channel, it's available in the early of 2016. But it was already on 4 Titan X Maxwells. It wasn't on the 4 Radeon R9 290s in Crossfire. Because the Counter-Strike 1.6 is using just a little bit of video RAM, about half of Counter-Strike Source. Keep that in mind. Anyways, minimum FPS 0.63, maximum FPS 3.98, average FPS 1.62. I'm not sure what happened there, guys, when we didn't use any physics. Something happened there, but let me real quick go ahead and without the anti-aliasing, let's go ahead and bench it again. Maximum visual preset without the anti-aliasing. I want to zoom in and show you how beautiful the game and how beautiful the level of design, and every single pixel is just right there. Maybe the game engine automatically reduced the game resolution scale. Maybe it wasn't the Nvidia driver. Maybe the games that allow through the game engine to reduce the gameplay resolution scale, maybe it boosted up the FPS. Maybe it went from 100% to 66%, and that makes sense, or maybe to 50%, and doubled the FPS. But we went from 1-2 FPS all the way to almost 10 FPS average. It was dramatic boost. I think it at least scaled down by 50%. This is what I'm assuming. But anyways, let's go ahead and bench it again, and this time I'm going to bring up the Yeah, maybe it wasn't the Nvidia driver, because I don't think the Nvidia can force artificially DLSS on a game engine that doesn't support it. I think it's impossible unless the AI will create the code, and it's in 2023 we're not at that level yet when AI throughout the runtime can create something, especially for the Nvidia drivers yet. And without any mistakes. It's not the year yet for that type of creations through the artificial intelligence. As long as I studied a lot artificial intelligence in 2023. So let's go ahead and zoom in. So this is check every single pixel detail, and we're going to check those little units. As again, I believe under 16K video resolution, 16K UHD, they're rendered 1024 pixels in height by about in width like 700 pixels. And let's go ahead and check out their details. Let's see how clear the details 16 sharp, even percent zoom. But as again, I'm zooming in into those pixels, and you know what happened when I'm zooming in into the, they're going to be so sharp, and when I'm going to zoom in resolution, going to be so sharp. This is my prediction, but as again, this is first time I'm doing that in this particular game, Warhammer 40K Dawn of War 3 PC game. But we're going to find out. As again, this is a single take, guys. I'm not scripted this, and I'm running it the way it is. So let's go ahead and zoom in. Okay, it's boosted up again, guys. It's boosted up again. FPS, 10 FPS, as you can see. And this is 200% 32K resolution zoom, like kind of, this is 300, 400, 500, 600. I think, guys, it's reducing the resolution 600%. So it's running 8K video resolution under 16K video resolution actually. But we're going to find out. It's right now, as you can see, it's smooth animation, and let's go all the way 1600%. Look at this, 1600%. I can see it requires some anti-aliasing on those little units, and the units are so small. So I believe it's running 16K video resolution in the menu when it boosts up to 10 FPS, but actually it's scaled down, reduce the actual scale resolution as game engine allows to 50% instead of 100% automatically by itself. The game engine is override the presets, I believe. So that's why it's 140, 11.39 as maximum FPS, and average FPS 7.69. I think when the game engine is about to crash, it's doing that in this particular game. I don't think it's Nvidia drivers. I don't think Nvidia can force anything artificial. As again I explained to you, it's impossible. I think it is what it is, and just before it's crashing, it's doing that. But I wanna make sure when it's going to be so slow. I just want to show you how beautiful under 16K video resolution those pixels. And I believe we just watched the 8K video resolution under 1600% zoom under Windows. But I showed to you guys how beautiful those pixels lookish. Look at this, it's stressing so much under this 16K video. Let's go ahead and zoom in at the beginning. This is 1600%. This is the aesthetic paper, which is probably like 4K video resolution or even less than that. Zooming in, this is what happened in Photoshop. Those pixels are static. They're not dynamic. They're not in 3D world. So when you're going to just zoom in into the texture on the full screen, this is how it's going to be. Just the texture, but not in 3D world. Open my eyes. 3D as 3D canvas, 3D scene, 3D surface, 3D world, max resolution for you. As you can see, it's still loading. It's very strong, especially zoom. It's creating additional stress. It's using some 2D libraries on the Windows operating system, and it's very stressful. But let's go ahead and have a look. Yes, now as you can see, it doesn't have any anti-aliasing, and you can see how it's beautiful, guys. Nope, now it's 8K video resolution. Now it's boost up, so it doesn't do it. Its engine is reducing and it's boosting up, but it's beautiful. Even like that, it's beautiful. But as again, I believe it's 8K video resolution. It's not what it is. Yeah, so I don't think if I'm going to enable the anti-aliasing, it's going to render with the anti-aliasing. So we're not going to enable the anti-aliasing because we are already overloading our video RAM. So with enabling the anti-aliasing, it's going to create an extreme pressure on the game engine, and if it does it without the anti-aliasing, I'm pretty sure it's going to override the presets in terms of the scale in the game. And as you saw by the FPS, it's just not scale at 100%. This is what I assuming as a software developer, as a game developer. The gameplay resolution is not at 100%, but it becomes at 50%, which is 8K video resolution. Check out my 8K video resolution preset and compare the FPS. If FPS will be the same, and I think the FPS was like 12 FPS under 8K video resolution at maximum visuals without the anti-aliasing. If this will be the case, then yes, indeed, this was 8K video resolution. But check out over the UHDking.com video description or video comments. I'm gonna post that video for you to check out and compare. Alright, let me apply this, and I'm going to return. I just want to show you how beautiful at maximum possible visuals the game looks like without the anti-aliasing. With the shadows to the maximum, everything is to the maximum, but look at this, 1600% zoom, and I can see his eye requires some anti-aliasing on those edges right there. This edges right here requires the anti-aliasing. I can see it, but it's beautiful. The metal is looking beautiful. The gun is almost great, but still those edges require some anti-aliasing on that 3D model. And textures does nothing about it, as you can see. It's done through the anti-aliasing methods to kind of blur it out at the higher resolution and scale it down. And I will try to apply, guys, in a second. I will quit the game. I will show you as a fact my PC specifications, but we already spoke about it. You saw about it. But and I will try to come back to the game, and I will try to enable the anti-aliasing and show you how anti-aliasing will be. Make sure everything will be amazing. With anti-aliasing under 16K video resolution, this game is going to look absolutely amazing, except the texture is not so sharp, but this is 1600% zoom. This is zoom at 1600%. Let me allocate that. Where is the thing? 1 second. Let me allocate that just right here. 1600%, see that? And it's still beautiful. If you're gonna do something like that under 4K video resolution, everything will be so pixelated and anti-aliasing. You're gonna see like it's going to look so ugly, unbelievable ugly. You're gonna see every single those edge is going to be like big square on screen. Beautiful, guys. It's just unbelievable beautiful. Let me show you 1000%. 1000% is going to look almost perfect. Not so perfect, as I can see that anti-aliasing on the head is not enabled, but it's not enabled, but it should be. You can see the effects. But let's bring 400%, which is 64K resolution, and it's beautiful. It's just beautiful, guys. I would say this is probably how 16K video resolution with 4 times anti-aliasing will look like. As again, if they're going to apply the anti-aliasing feature and algorithms to every single pixel on the screen, this is how it's going to look like. When I'm going to zoom in, it's going to improve by 4 times. But it's just beautiful. Look how beautiful it is. 400%, which is 64K resolution, which is unbelievable. It's like 3 gigapixels. 64K video resolution is above. It's like yeah, 3, almost 4 gigapixels render per each frame, because 32K resolution will be 1.8 gigapixels per each frame. This is 200%. This is 32K video resolution. Everything is beautiful, but as again, it's impossible to run 3D World in 32K video resolution, but it's possible to render 2D texture in 32K video resolution. As again, I'm about to demonstrate it for you, but check out how his beautiful X look like, 1600%, and right now, and it's beautiful, guys. Without the anti-aliasing, it's just unbelievable. Alright, so let me go ahead and quit the game. Let me introduce you. It's probably going to be a little bit over 1 hour, but as again, everything will be covered beautifully without the anti-aliasing. I'm going to demonstrate it to you and we're going to come back. So if it's going to stop the recording, there is a possibility it's going to stop the recording. There is nothing what we can do about it. So let me real quick introduce you to the computer. As you can see, I did all those tests without Nvidia ShadowPlay recording, so it wasn't within the recording in real time. But as again, 6 threads, 6 cores, 5300 megahertz, which is 53 multiplier as external frequency, which is 5.3 gigahertz. And for the AVX2 instruction frequencies, I'm running 52 multiplier, which is 5200 megahertz or 5.2 gigahertz. Okay. ASUS Z390 motherboard. The memory, the possible fastest DDR4. You can see latency delay below 45 nanoseconds, and it's pushing almost 50,000 megabytes per second bandwidth, which is 50 gigabytes for DDR4 in dual channel. This is a big deal. And I'm running 4 sticks, 8 gigabytes each, 32 gigabytes total. Running dual channel because the 390 supports only dual channel. That means each stick 64-bit, dual channel 128-bit, and beautiful bandwidth, almost 50 gigabytes per second or 50,000 megabytes per second in dual channel 128-bit. That means 64-bit will be like almost 24,000 megabytes. I would say like 23,000 megabytes for 64-bit though for one stick. This is absolutely amazing achievements for DDR4. And it's running 1600 megahertz, and external frequency will be times 2 because DDR4, which is 3200 megahertz output, but not CL16, not CL14, not even CL12, CL11. Right here, the latency. The lower latency is better, guys. Keep that in mind. 1T command. Also, the CPU cache frequency 48 multiplier, very crucial in terms of the latency delay and boost up a little bit of the bandwidth, even without touching the frequency. This is additional tip for you, but do not miss my overclocking tutorial on Intel 9000 series CPUs, guys. It's going to be the best tutorial if you having the Intel 9000 CPUs, you're building the computer from the used parts. You don't want to miss it. It's going to be amazing. All right, so 48 multiplier stable. As again, the fastest possible DDR because I was running the 2500 megahertz times 2, 5000 megahertz on an external output frequency, which is the Corsair DDR4 5000 megahertz CL18, unstable on this motherboard. The reason why, it's single rank, single bank, as you can see, but I'm running 4 sticks. That means single or dual bank, doesn't matter. It's going to be perfect dual channel. When you're running 4 sticks in dual channel, it's the best possible configuration, no matter how cheap or how expensive is your single bank or dual bank on your DDR sticks, DDR4. And the reason why it's not stable 5000 megahertz on this motherboard, and I don't think it's going to be stable on any motherboard for Intel 9000 series CPUs, but Corsair told me it's stable on the MSI Godlike carbon fiber motherboard. And Godlike edition. I have a doubt, guys. I'm using the Corsair memory since DDR1. I'm always with the top of the line. Their memory sticks always having trouble. Cannot run them as they specified. DDR1, DDR2, DDR3, and now DDR4. So I will never buy the top of the line DDR4 sticks again before the researches on them. Let me know how was your experience with the top of the line Corsair memory. I don't think they testing properly their sticks and marking them while misinforming the consumer. This is my thing. They do everything correctly. They do great water coolers, they do great cases, great everything except the memory. They cannot do the memory right, and Corsair is kind of memory company. They cannot do the memory right because, as again, they're using somebody else's chips and look like the quality control is not proper. But anyways, so just because the macro technology, and to be able to reach for sure 5000 megahertz on the DDR4, you need to have a Samsung B chip for the DDR4, and it's not the Samsung B chip, it's a Micron technology. So Micron technology doesn't like the high frequency, but it allows the low latency, and I think I utilize its memory at best possible capabilities. By the way, it was like $1,000 per 16 gigabyte for 2 sticks of 8 gigabytes, guys, from the Corsair. Okay, I'm going to utilize this memory probably for 13900K CPU just to extend the life of it. I also have the 4400 megahertz SCL16 sticks. I cannot wait to test them, and those are Samsung B, and I want to compare head to head and see how both will compare under the 9000 series Intel CPUs and under the 13900K Intel CPUs. That will be possible to run this at 5000 megahertz for sure if it's capable to do that. But as again, I have some doubts that this Micron chips can handle 5000 series. Keep that in mind on the external frequency on the DDR4. Okay, the Titan RTX one is overclocked. This is under CPU Z. Okay, 1770 under the boost. So this is the bench, guys. When we're talking PC games, something that rendering in real time and not utilizing all the CPU cores, you want to have as fast as possible single thread performance, and my score is 100 points higher than running stock. So stock is 550, 540, but right now I'm 636. Okay, when you're doing some 3D rendering, not in real time, where you're utilizing all the CPU cores, all the CPU threads at 100%, and as again, I'm building, guys, the UHDking's ray tracing CPU benchmark will be available very soon for the PC hardware enthusiasts, PC overclockers. You don't want to miss any additional videos about it over the UHDking. If you PC overclocker, PC hardware enthusiast, is going to be a Gucci. Hopefully it's going to be a popular, guys. I'm going to utilize all my skills as 3D artist, graphics designer, software developer, game developer, PC hardware enthusiast, PC overclocker, and I'm going to bring back value to you. You don't want to miss that, guys, all right? That piece of software. But anyways, when you doing the 3D rendering such as Cinema 4D, Blender, 3ds Max, it's going to utilize all the CPU cores available, especially all the 16 threads, without any question. So this is where you're going to take advantage of the multi-thread performance, but you're not going to take advantage in this particular game that we tested today and in 90% of the PC games, especially when we are talking 8K video resolution, especially above 8K video resolution, because the higher resolution, the less CPU utilization and the higher GPU utilization. Exactly what we want to have, all right, and see. So 6 core, 6 threads, which is physicals. I disable the hyper threading technology, which is additional logical cores, and I disabled the 2 physical cores to keep it stable at 5.3 gigahertz. So the higher frequency, the higher impulsing, the higher instruction per clock. Keep that in mind on CPU. So it was like a next generation of the CPU, even a little bit faster than that. In case I'm gonna demonstrate it as a fact to you. But 6 core for 9000 series Intel CPU scored 5.7 times. This is the Gucci. This is one of the best performance for the 9000 series Intel CPUs. All right. So let me compare with different CPUs real quick. So this is newer AMD CPU, which is 2 years newer, 5000 series flagship by AMD, and as you can see, I'm as fast single thread performance as that CPU. So in PC games, we will demonstrate the same performance, almost the same instruction per clock. Okay, but of course it's beating me in terms of the multi-thread performance because it's 32 threads, 16 cores, and AMD is just destroying Intel when every single core is utilized at 100%, even core per core. Okay, when we're talking same frequency, of course. And I'm running much faster frequency than that 5000 series. Anyways, 3950X, go ahead and smash that pause button. This is the same AMD CPU, same year, and as you can see, I'm destroying by over 100 points in terms of the single thread performance. Means in PC gaming, I'm going to destroy it, and of course, it destroy me in the multi-thread performance in something that as workstation, every single core, every single thread utilized in 100% makes sense. So smash that like pause button, and I'm gonna go through some CPUs. Maybe you're gonna allocate your CPU. Look at this, that 12900K CPU, even when I'm overclocked, destroying me 10% as minimum at the single thread performance. It's going to destroy me in PC game 12,900K 10%, but 13,900K is where the cherries are, guys. It's going to deliver additional 15% boost as minimum in terms of the PC games, because single thread performance is going to be out of the reach for the 9000 series. Even when 9000 series is overclocked to 5.5 gigahertz, the 13900K at least will be 10% faster at 99% of the PC games. Look at this, 10900K CPU, which is 10,000 series, next generation, which should bring the higher instruction per same clock, per same frequency, and I'm dominating almost by 40 points. So I'm going to be faster in PC games. Okay, just real quick, going to go through some CPUs, smash that pause button to compare your CPU or the CPUs that you're building, just to find out the clue. The best PC system will be from the used system, where you're going to utilize every single penny and take advantage and benefit as the best, guys. Do not buy the newest top flagship CPUs. Buy them. If you buy in the middle, the newest CPU, buy a middle grade. Okay, this is where you're going to benefit, and you can invest the rest of the money towards the next middle grade when time has come, and you're gonna pretty much invest almost the same amount of money as you purchase just one flagship CPU. But I'm doing it as a YouTuber because I'm trying to review as much hardware as possible and bring you some value back. So don't forget to smash that like button, because I'm running on my pocket. A lot of time, money, energy is invested. Share it with your friends. Check out my sponsors. I'm going to collect those pennies and I'm going to invest back into you guys. All right. So this is what's up, guys. As again, for those who's curious, Titan RTX was overclocked, as you can see, plus 100 megahertz under MSI Afterburner, plus 13 megahertz under the video RAM. Let me bring real quick the GPU Z, and I'm going to show you real quick how fast it was running. So when Titan RTX is overclocked, it's running way faster than RTX 3080 by a hair, not by too much, by a hair I would say. But when Titan RTX is running stock, it's slower than RTX 3080 video card. But as again, RTX 3080 video card is only featuring 10 gigabyte of video RAM. It's a faster video RAM, but it's less by over two times, and it's impossible to run this benchmark to render 16K video resolution in the Warhammer 40K Dawn of War 3 PC game in 16K video resolution, guys. You're gonna overload your video RAM and you're gonna crash with the blue screen, or the FPS will be so low because you're gonna offload a lot of data from a video RAM into the system RAM. Then you're gonna overload the system RAM and you're gonna start offloading into the storage. Or if you're going to have 64 gigabyte of system RAM, you're gonna be Gucci. But as again, if you're gonna offload 50% of the data from a video RAM into the system RAM, you're not gonna demonstrate that perfect GPU computing performance FPS. It's gonna slow down by a lot, or it's gonna demonstrate a lot of drop frames, because when you're using unregistered memory versus the quadrants, which is register, as I explained it to you, you're gonna have the drop frames, or it's going to crash, right? Anyways, let me show it to you guys. So when Titan RTX right now is overclocked, I'm pushing great performance. Pixel free rate 179 gigapixels per second. This value will decrease after I'm gonna bring to the stock. Pixel free rate 528 gigapixels per second, and bandwidth is almost 800 gigabytes per second. 800 gigabytes per second. And keep in mind that RTX 3080 video card with better video RAM is pushing 769 gigabytes per second, so 20 gigabytes per second higher in terms of the bandwidth. But when I'm going to bring it to a stack, let me demonstrate it to you, I'm going to lose over 120 gigabytes per second. So right now Titan RTX running stock, as you can see, through the MSI Afterburner. As again, you don't want to miss my video tutorial when I'm going to overclock the Titan RTX video card and RTX 2080 Ti video card. Step-by-step instruction is going to be one of the best video tutorials how to overclock Turing GPU architecture. But check it out, immediately we drop 10 gigapixels per second pixel fill rate, we drop 30 gigatexel per second texel fill rate, and that overclock we gain for free, guys. And in home safe environment. But as again, you are overclocking on your own, risk and expenses. Nobody going to compensate you guys. This is a very important disclaimer before you're going to start overclocking. I'm not advising you. I'm just saying it's safe, but as again, you're doing it on your own risk and expenses. As you can see, from 800 gigabytes per second, we went to 672 gigabytes per second. We lost 120 gigabytes per second additional boot in terms of our bandwidth, and that bandwidth is required, guys, to push that data from a second level cache on Turing GPU architecture, which is much faster than Nvidia RAM. Second level cache on Turing GPU architecture is 1.8 terabyte per second based on my macro benchmark in CUDA on those CUDA cores. I read that in the manual, on a retracing manual with the CUDA course, okay? While I was developing the CPU retracing benchmark, I read a little bit of the GPU retracing benchmark just to gain some information about retracing. So imagine 1.8 terabyte pushing into the video RAM, and the higher bandwidth on the video RAM, the faster the data transfer will happen, okay? The copy, the data, but it's pushing not from the video RAM, it's pushing from the GPU, and GPU is unbelievable fast because it's utilizing the level first cache, which is much faster on the GPU than level second cache on the GPU, which is the fastest. As again, NVIDIA using the dual scheme on the pre-caching, level 1 cache and level 2 cache that's located on the GPU, but level 1 cache is located per each streaming multiprocessor unit, and 64 of them per seven, actually, I believe not 64, 72 of them, or 64 per each multiprocessor. I forgot. I'm going to show it to you in a second. Per each streaming multiprocessor unit, and they're utilizing per each streaming multiprocessor unit the level 1 cache, and it's the fastest. Nobody know how fast it is, but I think it's twice as fast as level second cache on the GPU. And then level second cache is utilized on all the CUDA cores, on all the streaming multiprocessor units, and it's slower because of that. It's shared. And then it's using the video RAM, and then it's using the system RAM, which is much slower than video RAM, and then it's using the storage when system RAM is overrated, not enough. Hopefully, guys, this makes sense. So I show it to you guys. I show you this as a fact, and let me real quick go ahead and demonstrate real quick for you why. Let me open up the AIDA64 business. I'm using the business version. Why? Because AIDA64 business version is supporting the it's fully supporting, guys, the 2048 threads or 1024 cores, physical cores, the whole software. Can you believe that? While the AIDA64 Extreme, I thought the Extreme is better than engineering or business, but business is top of the line. While the Extreme is only supporting like 256, I believe, or something like that, or 512, something like that, logical core threads maximum through the benchmarks, okay, and can display. Anyways, through the utilization through the software. So AIDA64 business is the best, but I gave away a lot of AIDA64 extreme business and engineer version over my YouTube channel as giveaways. So go ahead and subscribe, watch my videos as first watcher, first follower, and you're gonna win some games, some hardware, some software. Support me, guys, visit my sponsors, and everything will be Gucci. Okay, I need your support. As you can see, unique videos, not like one of those copycats copying each other, and some of them like zombie repeaters. They saying the same information, misinformation over and over and over. Anyways, so as you can see, guys, this is the CPU 53 multiplier completely on 6 cores as external frequency. This is the features that support it. Let me real quick show it to you for those people who is curious. Real quick, just because it's the world's first 16K video resolution, I'm going to demonstrate all possible information that you need to know. Okay. So let's go ahead and switch now to display the GPU. This is important things right here. So here we go, guys. So pixel pipelines 96. Okay. Texture mapping units 288. Total CUDA cores 4608 version 6.5, which will be Turing GPU architecture. And the difference between the CUDA cores is big because what is the CUDA core? CUDA core is pretty much the generation will be a reflection of the level 1 cache, how fast it is and how much it is allocated per each streaming multiprocessor, and the level 2nd cache as well, because this is what the CUDA cores, okay? But CUDA cores, most of them will be relay on level 1 cache. So the higher level 1 cache, the better. And through newer generation, they increasing the level 1st cache because it's getting faster. It can push the higher bandwidth in terms of the terabytes per second, not even gigabytes, but terabytes per second after the Turing GPU architecture for sure. And even after the Pascal GPU architecture. And level 2nd cache, as I told you, 1.8 terabytes per second based on benchmark on Turing GPU architecture. I got the information that ADA GPU architecture 8102 GPU, the full ADA GPU architecture, is capable to push 4.8 and all the way to 6 terabytes per second on level 2nd cache in the GPU. Can you believe that? So it's going to be the new Titan ADA or probably RTX 4090 Ti, and I cannot wait to place my hands on it. It's probably going to feature 48 gigabyte of unregistered video RAM, GDR6X versus the registered GDR6X 48 gigabytes on a Quadra, which Quadra 6000 RTX 6000, but ADA. So it's going to be a copy of that, but it's going to be unregistered video RAM, and I think it's going to feature 48 gigabyte. It's probably going to be RTX 4090 Ti or maybe Titan ADA. I think it's going to be Titan ADA, guys. All right. So 72 multiprocessor. Ray tracing core 72, but let me see. Right here, streaming multiprocessor, not 64, but 72. I was right. So 72. So that each streaming multiprocessor is utilizing, guys, 64 kilobytes, but it's over 64 kilobytes. It's actually 96 kilobytes of the level 1 cache per each streaming multiprocessor times 72. This is how much level 1 cache, and it's extremely fast. Then the slower will be level 2nd cache, which is still on GPU, and then off the GPU video RAM, and then completely off the video card system RAM, and completely off of the motherboard storage device. Okay. But as again, it depends what kind of storage device you're using. If it's M.2, that could be on motherboard and could be as fast on the PCI Express version 5, very fast as well. But it's not, will never push that type of bandwidth. It will never push as video RAM is capable, which in our case was 800 gigabytes per second. You're not gonna find any storage device that can push even 600 gigabytes per second. All right. So as you can see, level 2nd cache in Turing GPU architecture 6 megabytes. As again, it's shared on all the CUDA cores and all the streaming multiprocessors. It depends what kind of parallel instruction computing task is going on. And local share cache is 96 kilobytes, which will be 64 kilobytes allocated for sure, and additional 32 kilobytes will be for the physical addresses, where it's gonna say, look, this is a physical address, this is where the texture is, but right now we're gonna shorten it into digital virtual address, and then it's gonna use less kilobytes in terms of the for the level 2nd cache, in terms of the video RAM, but it's going to know exactly where it is because it's located in level 1 cache on the GPU, and its fastest allocation is calling that where exactly that location of that URL on the local storage device of the texture, and etc. And so it's going on so fast because level 1 cache is the fastest for the video card for the GPU that can be accessed. Hopefully, guys, this makes sense. Everything was explained to you. And now why I'm not sure why I'm saving the commercial, because I have the registered version of the ADA64 business, but why the Let me show it to you. As you can see, it's registered under the desktop, under the Windows operating system, even with the ADA, ADA 64 Business Edition version. It's registering 16K video resolution as resolution. Okay. 60 Hertz raster display. So indeed rendering natively because it's registered as natively. Okay. And let me show you why 16K video resolution is maximum as 3D world, 3D surface, 3D canvas. It depends what kind of API you're using, open source or commercial. They all call different, but here we go. XYZ coordinates, 16K video resolution, and as you can see, 16,384. This is exactly how much CUDA cores and EVGA GPU architecture RTX 4090 video card, which is not, by the way, not the full AD102 GPU by Nvidia, which will feature over 18,000 CUDA cores. And Nvidia boss, Nvidia CEO, and Nvidia founder Jensen Huang is mimicking to us an anecdote. Look, I have more CUDA cores on full AD 102 GPU by the Nvidia, which is full ADA, that will be available in 2023. That 16K video resolution in terms of the width. Okay, that means that I can at least process 1 pixel per each CUDA core without any issues. Okay, that's what he's mimicking, and above than that with the full AD102 GPU. Hopefully guys, I explained it well. So as you can see, as I told you, to the texture 32K video resolution, but not XYZ coordinates. Okay, maximum 3D surfaces, again 16K video resolution, XYZ, and this is going to be under the CUDA API, rendering API by the Nvidia, Direct 3D API by the Microsoft. It says that it is Direct 3D API, but not 12, it's 11. Due that it's Windows 10 Professional, supporting only DirectX 11 API through the operating system, and this is pulling the information through the operating system. This is not pulling information through the game, that all the games are closed right now. Hopefully guys, this makes sense, all this information. And this is the OpenCL, which is crucial in terms of the ray tracing as well. You can use the OpenCL on the GPU though, and also on the CPU as well to render, but it's hard to, through the OpenCL, render ray tracing on the CPU. Most of it done on the GPU, but it can be hybrid CPU and GPU through the OpenCL. I'm going to explain it guys over my YouTube video when I'm going to show you how I'm going to develop my UHDking ray tracing CPU benchmark. It's going to be, all this information will be covered. You don't want to miss it. It's going to be unbelievable video. You're going to learn so much. I'm going to share so much data with you. It's going to be just unbelievable. Anyways, so as you can see, 72 as cores per each streaming multiprocessor unit, and total 4,608 CUDA cores, and under OpenCL, still maximum 3D image size, XYZ, 16K video resolution. Okay, same scenario as I told you. No matter what kind of API you're using, the open source or commercial, it doesn't matter. Everything will be just the same. Here's some information about this API. Go ahead and check it out. This is what is supported by the Titan RTX video card. This is crucial for the software developers, game developers. If you're trying to implement something unheard of, go ahead and smash that like button and pause button to learn some more. Vulkan API, same thing guys. Under the Vulkan API, it's going to be same thing. Maximum 3D image size, 16K video resolution, XYZ, 2D 32K resolution. Okay, as a texture, all kind of different approaches. Here's some information for you, but you got an idea. All right, some values that's supported by the Titan RTX video card, and it's pulling from the Nvidia driver from those variables, those maximum values, as you can see. So it's detailed, it's precise. If it didn't pull the value, that means it's not supported by the Nvidia driver, by the particular Titan RTX, at least officially by the Nvidia. Hopefully guys, this makes sense. So everything was covered, and now we're gonna do the last test. Now we're gonna do the extreme. Now I'm going to go ahead, hopefully it's recording. Now I'm going to go ahead and try to started again. But before I'm gonna do it, just because this is the world's first 16K video resolution in Warhammer 40K Dawn of War 3 PC game, world's record and world's first YouTube video uploaded to YouTube, I decided to give you a little gift by the UHDking. And here's the gift, guys. I don't have the game, which is Warhammer 40K RTS real-time strategy, but I have some nice modern, also futuristic real-time strategy PC game, which will be Act of Aggression Reboot Edition, which is the kind of newer version of the Act of Aggression. Beautiful real-time strategy. Go ahead and check it out. It's looking like a Generals, Command and Conquer Generals with updated graphics. You're gonna love it a lot. And to celebrate the Warhammer 40,000 Dawn of War 3 PC game in 16K video resolution, which is 15,360 pixels by 8,640 pixels, or 132.7 megapixels, as the world's first 16K UHD gameplay and 16K video resolution benchmark, vector and first data towards that vector direction. Okay, that was uploaded on YouTube, and was uploaded by UHDking. Or I play 4K, aka I play 8K, aka I play 16K. Alright, guys, and this is the code. This is on Steam, guys. This is a Steam version. To the first activator, please let me know who you are. Go ahead and use this code. Please watch this video on 4K resolution, but the best possible experience will be on 8K video resolution. Hopefully still recording the video. I think I have like 100 gigabytes to go, and if it's going to be over 1 hour, it's going to overload the 100 gigabytes, but still hopefully it's recording. And I'm recording at 100 megabit per second. Go ahead and use that, guys. This is a gift for you. Don't forget to smash the like button. If you're not the first activator, this is for the first activator. Please let me in the video comments below who you are. Do not state your name and something like that. State that I was the first activator. Thank you so much. So people will know, so they're not gonna activate it 1,000 times and not gonna get frustrated. Okay, be nice, guys. And yeah, so let's go ahead and get going, guys. So I'm gonna go ahead and execute it now. Now we're gonna run that extreme. Today is January 23rd, 2023, for those who is curious, and we're about to execute that extreme. And I want to show you at least how game engine looks like in terms of the details when the anti-aliasing is enabled, if it's not going to crash on us. Okay, hopefully it's not going to crash on us, but we're about to find out. Okay, Titan RTX is running stock. Let me overclock the Titan RTX real quick. We don't want to run it stock. We want to improve our bandwidth, at least for the video RAM, because the resolution is crazy. We're pushing a lot of data per second. The higher bandwidth on every single application, such as level 1, level 2 video RAM storage, the better. Keep that in mind. System RAM, the higher bandwidth is better, but DDR4 I'm pushing the 50 gigabytes per second. Guys, on DDR4 I'm almost pushing 50 gigabytes per second, while my video RAM is pushing 800 gigabytes per second. Can you believe this? It's 15 times higher, not even 15, 17 times higher we're pushing theoretically, but I would say at least 15 times higher in terms of the real life bandwidth. We're pushing the video RAM is faster than DDR4, GDR6, and this is GDR6 by Samsung. The RTX 3090 video card by Nvidia, RTX 3090 Ti or RTX 4090 Ti video card is having 1 terabyte per second bandwidth on a video RAM GDR6X. This is just unheard of. Anyways, I overclocked that, as you can see, 100 megahertz on GPU, 1300 megahertz on video RAM, which will be outputting as external frequency 2600 megahertz output because it's GDR6, but 1300 megahertz through the MSI Afterburner, because the developer of MSI Afterburner didn't include external frequency, just include internal frequency, but just because GDR6 it's times 2. Anyways, let's go ahead, guys, and bring it to the anti-aliasing, to the maxed out. Anti-aliasing on. And again, look at this, it's registered 7-8 FPS. Look at this, it's registered 7-8 FPS. Let me actually try to do it without the anti-aliasing. The game engine actually is registering 8 FPS exactly as we were pushing. Let me apply. Okay, it's applied. Let's go ahead and run one more time benchmark. I think maybe I should do the reboot when I did the ambient occlusion of the units at maximum and physics at high. I probably should do the reboot. Even the game didn't ask us to reboot, but most likely in this particular game, Warhammer 40,000 done for 3 PC game, you can reboot every time you switching the preset if you want to utilize that feature at that preset exactly. Look like the game engine is not capable to do it throughout the real time, throughout the run time. See, it's boosting immediately. And I'm not sure why it's boosting. There is a possibility, as again, I don't think it's scaling, guys, at 100%. I don't think so. I think it's just switching to 50%. Go ahead and watch my 8K video resolution. I forgot what was the score. I think it was 12 FPS at maximum visuals without the anti-aliasing. If this is going to be the case, then it's artificially lowering from 100% to 50%. Okay? And FPS is a little bit lower versus the 8K native because look like it's using some elements at 16K video resolution. It doesn't scale everything at 50%. Look like something is probably sticking at 100% at 16K video resolution. That's why my FPS is a little bit lower than on the 8K video resolution native. This is what I'm assuming as a game developer, as a software developer. Anyways, this is the FPS, and this again, I don't believe it's real FPS. But let me apply the settings, and here we go. And I'm going to use the anti-aliasing now. Okay, anti-aliasing is on. Apply. Ooh. Yeah. As you can see, data. It didn't reboot it, but let's go ahead and have a look without the reboot. I'm just without the benchmark. It's probably going to, as again, scale back to 50%. But without the benchmark, let's go ahead and have a look at this dude right here. Indeed, anti-alias. See that? The eyes, the edges are perfect. This is 1600% if I'm not mistaken, right? Where is that? Yup. No, 1100 even. Let me use this 1600%. But guys, it's perfect. The edges on that 3D model is perfect. 1600%. Yup, it's anti-aliased. It's beautiful. I didn't see any sharp edges. Even on the gun, check it out. It's just unbelievable, guys. Look how everything is beautiful. It's just, guys, even this one looking on another level. Let's get to that little guy, and I will try to run the benchmark. Check it out. His head is beautiful, guys. Anti-alias, I didn't see those hard edges. The gun is beautiful. I didn't see the hard edges. Beautiful smooth lines right here without those kind of squarish edges. It's just beautiful. And as again, this is the original game. You can modify the game and increase the pixel details in terms of the how it's going to be defined with the higher resolution of the textures. And it's going to utilize a little bit higher of the video RAM. It's not going to be double if you're going to double the texture size of that pixel count, width and height, but it's going to increase by about, I would say, 30% in terms of the video RAM utilization. So most likely you can also be Gucci with 24 gigabyte if you're going to improve, if you're going to make every single texture in 4K, and then it's going to be beautiful when you're going to zoom in over here. But as again, the best way will be 48 gigabyte of video RAM, and 48 gigabyte of video RAM, guys, will run 99% of the games that was released before 2020 without any issues, without any offload from the video RAM into the system. It's going to be beautiful, healthy video RAM utilization by the GPU, by the CUDA cores. After it's going to overload the level 2nd cache and level 1st cache. All right. But 1600%, this is 500%. Look how everything is beautiful. It's just unbelievable. 400%, this is 64K video resolution. It's just Look how beautiful everything is. I'm gonna take a screenshot before we're gonna run it, guys, and then I'm gonna run the thing. I'm gonna use it as a thumbnail for you. You're gonna recognize it by that. Let me zoom it like this, and probably close as possible like that, and this is how we're gonna use it. Maybe zoom out a little bit more. Yeah, this is going to be fantastic. Let me completely zoom out. Close the zoom tool. I'm gonna take a screenshot for you guys while I'm recording with Nvidia ShadowPlay. Look how beautiful Nvidia ShadowPlay, and it even didn't shake, but hopefully it's still recording. I didn't see that video window, but I still see that little icon at the bottom right corner. See that little green thing right there in the little corner? It's still recording. This is how small that at maximum zoom that icon that is still recording. Hopefully it took the picture. Hopefully it took the screenshot. I probably should do a screenshot after the video recording. So right now I will try to go ahead and do the video test. It's going to be beautiful, but let's see if we can read his writing right there actually. I think the texture, the level of details on the texture is not capable to display that writing exactly. Or maybe it is capable. Yeah, I don't think it's capable. I think it's a little bit blurred out. The whole texture, the pixels are not defined, because I cannot read it, and yeah, it's something written there, but it's kind of mimicking like something there. But if you're gonna create 4K video resolution, you can define it, then you can read it for sure when you're gonna zoom in. But look how beautiful, how details on that. Zoom into this dragon in 4K video resolution. Everything will be so pixelated. Over here, everything is so smooth. Everything is anti-alias. Everything is just unbelievable, guys. All right, so let's go ahead and do the test, and we're gonna go ahead and wrap up. So guys, everything was covered. This is if you Warhammer 40K Dawn of War 3 fan. You smash the triple times like button, share with all your friends, post it on all the forums. This is rock and roll right here. Apply it again. Probably should reboot, but let's try it without the reboot. Let's see. We're gonna see how it's gonna go. If the FPS will be like a little bit below 8 FPS, below 7 FPS, that means that anti-aliasing is applied, but we're scaling down from 100% to 50%. I'm pretty sure. My hot chocolate is already cold with the mix of the coffee. Guys, donate me. Show me the support. You want to see those beautiful, unique videos? I'm the first YouTuber as the first pioneer that's showing you 16K video resolution the way it is, without any lies. Yeah, it's scaled down immediately to 10 FPS, and but it's anti-alias for sure. If I'm gonna zoom in, let me do that. You're gonna see it's perfect. Let me do that. Check it out. Yep, everything is. This is 1600%. Everything is beautiful. Check it out. The level of, yeah, even it's probably 8K video resolution, and everything is so beautiful. I didn't see any edges on that model. It's just beautiful. And if you're gonna increase the level of texture to 4K video resolution, it's gonna bring a little bit more details. But as again, that texture is still not display at full resolution and doesn't display the full amount of pixels. And the game engine in this particular game is scaling down from 100% to 50%. It's overreading automatically, I believe, just to avoid the crashing the game, and the FPS almost the same. So the Turing GPU architecture in this particular game, anti-aliasing method, it's like nothing. It's still applying that. We saw it. It's beautiful, but it's like nothing. It's gonna take it like it's nothing, and it's gonna chew it like it's nothing. Ada Ampere will do it even better, and Ada will do like anti-aliasing or without the anti-aliasing like it never was applied, but as you saw, it's applying even under 16K video resolution for sure. Alright guys, well I guess that's it. My name is UHDking, or I play 4K, aka I play 8K, aka I play 16K. Go ahead and check out UHDking.com or UHDking I with a 1 or 15,360 times 8,640.com or iplay16k.com for more 16K video resolution gameplays or any information that I'm going to share with you as the first pioneer, as the first gamer in 16K video resolution, 16K gaming, 16K gameplays, and 16K videos, because I'm developing FFmpeg++ application that will utilize the 16K video encoding in real time. It's not probably going to be in real time with today's technology, or actually it is. On my Dual Xeon 2699 V3, it was like 2-3 FPS if I'm not mistaken, so in real time. So on the newer Ryzen's 9000 series, 9 series, 7000 series, and 9000 series CPUs, and the Intel 13900K and Intel 14000 series CPUs, it's going to be Gucci, guys. Go ahead and check it out. A lot of information will be shared. Check out the video description, visit my sponsor, support me, check out the video comments. I'm going to put a lot of relevant videos, to related videos to this topic, 16K UHD, in the future, throughout all kind of different tests on video cards, CPUs, systems, benchmarks you want to miss. And smash that like button, share it with your friends, guys. Have a good morning, good day, good evening. Till the next time.